Hi, this is Miss Oliva. I'm now going to go over algebra functions and compositions, and this is for 1.8 if you're in my Math 161. So let's get started. Okay, so algebra of functions means you're taking functions, different types of graphs basically, and you're doing some algebra with them. You're adding, you're subtracting, you're multiplying, you're dividing, stuff like that. So if you're doing something like f plus g of x, it means you're taking an f function and a g function and you're adding them together, but at the end, you're still going to just have another function that has x in it. So you're not going to get like an answer like 16. So f is 2x plus 3. If we want to just make sure we don't miss anything, we can use parentheses, plus the g, which is x squared minus 1. But then in this case, those parentheses aren't really doing anything, right? There's nothing outside to distribute or anything like that. So we can basically ignore them and just add whatever we're allowed to add, meaning like terms. So x squared has nothing to add to it. The 2x has nothing, but I can combine the 3 and the minus 1 to get 2. So that's it. You just add what you're allowed to add. Subtracting, same thing. You just have to be a little more careful with the subtracting. Make sure you write it in order, and this time the parentheses will matter because we're not just subtracting the 2x, we're subtracting this whole thing. So do you see how that negative is going to need to be distributed? So what we really have here is x squared minus 1 minus 2x minus 3. And now I can combine whatever I'm allowed to combine. So that is just this minus 1 minus 3. So negative 1 minus 3 is negative 4. So adding is pretty simple. Subtracting isn't bad, but you need to make sure you subtract all of that. So you need to distribute. All right, F, if it's a little tiny dot, or G dot F, this means multiplication. So I'm going to take the G and multiply by the F, which can mean a lot of different things. But in this case, since I have 2 terms times 2 terms, I'm going to need to FOIL. So this times this times this. So I would get 2x to the third plus 3x squared. Now I'm going to go multiply the negative 1, negative 2x minus 3. And then just see if there's anything you can combine, which in this case, there is not. Because there are no like terms. We have an x to the 3, an x, or x cubed, x squared, x, and just a constant by itself. So nothing can be combined. All right, g of f means to divide, but this time we have an actual number. So I'm going to plug this number into both of these things and then divide, because that'll make it a lot easier. So if I plug the negative 2 into g, I get negative 2 squared minus 1. And if I plug the negative 2 into f, I get this. So on top, I get 4 minus 1, which is 3. And on the bottom, I get negative 4 plus 3, which was negative 1. So basically, my answer is negative 3. Same thing with the next one. I can put the 2 into both things and then multiply. So 2 into the h gives me this. And then 2 into the g gives me this. So this is 4. Square root of 4 is 2 times 4 minus 1 is 3. Final answer, 6. All right, now I'm back to having an x. So this is not going to be as easy as just putting a number into each thing. And this time, instead of the dot, I have this open circle. This means something different. It actually means the exact same type of thing as this. So these are 2 different ways to write the same thing, which is a composition, which means we're putting a function inside another function. So G of, they call that of, G of H really means I'm going to take whatever the H function is, the whole thing, and put it into the G, which means I'm going to put it into the G function instead of the X. That's how you put a function inside another function. So what I like to do is start with the first one and leave the space for that second one. So since G is x squared minus 1, I'm going to write it like that. So instead of the X, I'm leaving a big old blank so that I can now put in whatever function I want to, which in this case is the H. So now this is me putting the H function inside the G function. And then you just see if there's anything you can do to reduce it. A square root being squared really just wipes out. So you have 2x, and then you have this minus 1, and you can't go any further because those are not like terms. Okay, next one is the same type of thing. I'm going to put the G function inside the F. So I'm going to start with the first one, the F, and I'm going to leave my spot. I took the X out and I left a big old blank, so now I can put in the G function, which is x squared minus 1. So do you see how that's me putting the G function inside the F function? And then make it as nice as you can. So in this case, I can distribute the 2. And then I can go one step further with the negative 2 plus 3. Okay, and finally a composition with a number. So I'm not going to put the 3 in both things this time. If you're doing a composition, you need to go in order. So you start with a 3, you put it into this function, so in this case an F, you're going to get an answer, and then you're putting that answer into the G. So when we put 3 into the F, we get 2 times 3 plus 3, which is 9. So now 9 is what I need to put into the G. So since I'm putting the F function into the G, but I want to find out what happens when it's 3, I plugged the 3 into the F first, I got 9. And now I'm going to plug the 9 into the G function. So 9 squared minus 1, which is 81 minus 1, which is 80. So only for composition, if you have a number, plug the number into that function, get an answer, plug it into the one before it. Okay, same type thing, but with some fractions. And they're also going to ask us to write the domain. And I believe they wanted to write it as an interval. But first, let's just deal with what S over T is. So if my S is x minus 1 over x squared minus 4, and my T is x minus 2 over 1 minus x, I'm now going to be able to change this because this really is saying this function is being divided by this function. So instead of dividing, I'm going to do keep, change, flip. So I'm going to keep this one the same, change it to multiplication, and flip that bottom function. Now I'm going to reduce if I can reduce, but if I can't, I'll just leave it like this. So as far as the domain, when we have fractions, the easiest way to think of the domain is just to think of what do we not want to happen. And we never want the denominator to equal 0. So first of all, since we have two fractions here, let's figure out when this would be 0 and when this would be 0, and then we'll look at our final answer. So one thing we don't want to happen is we don't want x squared minus 4 to be 0. So that would mean we don't want x to be 2 or negative 2, right? When we take the square root of both sides, we get a plus and a minus answer. We also don't want this to equal 0. So that means x can't equal 1. So I'm finding all the things we do not want, and then we'll talk about how we actually write that. So in our final answer, we've already covered the x squared minus 4, right? But we haven't talked about the fact that we also do not want this to be 0, which would mean x would equal 2. So in our domain, we want to make sure we do not include -2, 1, and 2. And that covers everything because this 2 was already covered. So how do I show with an interval, which means like the parentheses and the infinities, that I want every single number except for these? Well, this is the kind of annoying one to write with all the parentheses and the u's, where you start with negative infinity, go until the first number you don't want, union, start there again, and go to the next one you don't want, union, start there, go to the next one you don't want, start there, and go to infinity. So this is a very fancy way of saying we want every single number except for -2, because we're not including that because of these parentheses, except for 1, and also except for +2. So this gets some getting used to. Okay, now there's something called the difference quotient. The difference quotient is plugging things in, but it's with this very specific formula. So all this formula is saying is take your function and first plug in x plus h, then take your function as is, because it's an f of x how it normally is, but subtract that carefully. Sometimes you need a big old parenthesis around whatever you're subtracting, and then divide the whole thing by h. So let me show you how that would look. So I'm first supposed to take my f of x, but I'm going to plug in x plus h. So doesn't that mean plug that in here? So this is me just setting up this first part. But now I'm supposed to take that and subtract f of x as is. Here's where most people mess up. That's not correct. I need to subtract that whole thing. So show it with parentheses, which means that negative is going to end up being distributed. All of this is just over h. Now I'm going to make this as nice as I can. I'm going to distribute the 3 in the front, distribute the negative, and see what I can combine. 3x minus 3x, that just goes away. So I still have the 3h. -1, oh, I made a mistake here. Negative and a negative should have given me a +1. So I have a -1 plus 1 that also wipe out. So all I have left on top is the 3h over h, and now I can also reduce those h's. So after all that work, my final answer is just 3. So let's try one more that's a little more complicated. First step, wherever the x's are, put x plus h. And then now I'm going to subtract the original function, but I'm going to put it in a big parenthesis so I don't hopefully forget to distribute, and put that all over h. Now let me make this look nicer. This is tricky because remember, x plus h squared really means x plus h times x plus h, which is x squared plus xh plus xh plus h squared, which is this. So all of this is what x plus h squared really is. So I still have my 2, but now if I multiply that out, I would have this minus 3x minus 3h. Gotta be really careful with these negatives. Minus 2x squared, negative times a negative gives me a plus 3x. Finally, I'm going to distribute the 2. And then see what I can combine. I have a 2x squared and a negative 2x squared. I have a negative 3x and a positive 3x. And I think that's it. So I have 4xh plus 2h squared minus 3h all over h. A lot of people would stop there, but if you have an h on the bottom and you notice that every single thing on the top has an h, you can pull that h out so that you'll be able to cross them out. So if I take out an h from all three of these things, what would I have left? 4x plus 2h minus 3. Final answer, 4x plus 2h minus 3. Okay, so that's just a very, very specific formula, but there's how you use. Okay, more compositions. So this we've already talked about. I'm going to take the 3. I'm going to plug it into G first. So that gives me square root of 3 times 3, which equals square root of 9, which equals 3. So that's a coincidence that I plugged in a 3 and I got a 3. But now I'm taking that and putting it into F. So 3 squared minus 3 times 3, 9 minus 9 equals 0. So this whole thing equals 0. Here I'm going to take the negative 2 and put it into F first. So negative 2 squared minus 3 times negative 2, 4 plus 6, 10. So I'm not done yet. So I guess I'll do it down here. I got 10 here. So now it's 10 that I'm going to plug into the h. So I put the negative 2 in the f function. I got 10. So now I'm taking the 10 and put it into the h, which is 6 times 10 minus 3, 57. Okay, for the next one, we're doing the compositions again, but this time with the x's, which is a little trickier. So I can't just like take a number, put it in the G first, and take that new number, put it in the F. I'm forced to kind of use the whole functions. So remember, I did do this one a minute ago, where I start with the first function so I can leave the space so that then I can put that second function inside it. So negative 4x plus 3, I wrote negative 4, left a big space, plus 3. And now what do I want to put in that parenthesis? The G function, which happens to be x squared. Not much to do to make this nicer. So that's our final answer. Now I'm doing the opposite. So I'm going to start with the G function this time. Leave my space. So that now I can put the F function inside it. To make this nicer, I can do this squared, which really means negative 4x plus 3 times negative 4x plus 3, which equals 16x squared minus 12x minus 12x plus 9, which equals 16x squared minus 24x plus 9. So I did it. F of G got this, G of F got that. So now they're asking me, are the two things equal? In this case, No, but sometimes they will be, and that means something special. But I'm guessing we're going to get to that soon. Okay. One more, but with fractions again, and also asking me for that domain interval. So I need to put the G inside the F. So I start with the F, leave my spaces. I now put the G function inside. So right now I can see that I have some issues as far as what I don't want happening. I don't want, so I'm going to go off to the side here. I don't want x squared minus 4 to equal 0. So when would that happen? Square root, square root. So I get 2 answers. So I already know from the start that I don't want 2 or negative 2. But now let me make this as nice as I can and see if there's anything else. So I'm going to leave the 10 over x squared minus 4. That's fine. On the bottom, I'm going to get a common denominator, which is going to be the x squared minus 4. So I multiply the bottom and the top by x minus 4. I'm going to come over here and just work on making the bottom nicer, and then we'll go back over here. So I have 10 over x squared minus 4 plus 16x squared minus 64 over x squared minus 4, which equals 16x squared minus 54. That was just me getting a common denominator so I could add these together and get it as nice as I can. So now I'm going to go back to the problem. The top I left the same right now, but the bottom I was able to change into this. And now that I have a fraction divided by another fraction, I can do the keep, change, flip. So top stays the same. I multiply and flip the bottom. Nice thing about this is I have an x squared minus 4 and an x squared minus 4 diagonal, so I can just cross those out. So I end up with 10 on top, 16x squared minus 54 on the bottom. I can set this equal to 0 to find out if there's some other numbers that I don't want. So 16x squared equals 54. Now I could divide by 16. Not sure if that is nice. And then square root. Let me make sure I didn't miss anything here. Because I thought it should be nicer. But either way, when we go to write our denominator or our domain interval, we're just going to do the same thing we did a minute ago. Negative infinity to the first thing that we don't want, that to the next thing, that to the next thing, and finally that to infinity. So we've already done this, but I just wanted to show you the keep, change, flip being used in there. Okay? So I'm not, I think you would get a nicer number. So that's why I don't want to keep going with the number that's not so nice there. All right, now for a word problem. The cost to buy tickets online for the show Riverdance is $70 per ticket. The first thing they want me to do is write a function that would just deal with the cost of buying the tickets. So they're even telling me, hey, make X the number of tickets. So if it's $70 per ticket and we're buying X tickets, wouldn't the cost just be 70 times X? That's how much it would be, right? So now for B, it's adding some more stuff going on. B, there's also a sales tax of 6.5% and a processing fee of $7 for a group of tickets. So you just have to pay this once. Write the total cost T of A for $1 spent on tickets. So ignoring what we just did with the 70x, if now we just said that, hey, however much we spent on tickets, let's call it A, how much would we have to pay overall if we're also doing this tax and this $7 processing fee? Well, whatever A is, that's our total amount we have spent so far on tickets. We need to find out what 6.5% of that is to figure out the tax, right? So, well, first of all, we have to pay whatever that is. So let's say we've so far spent $300 on tickets. What's our total cost? Well, it's going to be that 300 plus this tax, which is 0.065 times that amount that we spent, right? You don't just add 0.065, that means nothing. 0.065 times A would get us the tax. And then also plus that 7. We can make this a little bit nicer because this is technically 1A plus this A. So I could put those together and say, this would be my total cost. This times however much we spent on the tickets plus 7. All right, so C is now wanting me to do a composition. They want me to do T of C of X. So my final answer is going to have X's in it. So they want me to take the C function, which is this, and plug it into the T function. So the way I've been doing this so far is I start with the T function, right? And I leave my space. And I now plug in the C function. And then we make that nicer if we can. So I'm going to go ahead and multiply the 70 and the 1.065. Just to like make it a little bit nicer. So this would be my function now to really find out how much I spent on tickets. However many tickets I'm buying, I'm multiplying this because this includes that tax, and then plus this one-time fee of $7. So D finally is asking me to find T of C of 6, which basically means I could plug the 6 into the C function, get an answer, and plug that into the T. But since we've already found a new function that would be this T of C, I can just take my 6 and plug it in here. So 74.55 times 6 plus 7 should give me my total cost for that many tickets. For 54.3, but with money, we usually write it with 2 decimals. And so it said, find this and interpret its meaning. So what does this mean? This means it costs that much to buy 6 tickets to Riverdance. Okay? All right, another composition, except this time it's the opposite. It's giving me the final answer. So it's saying, what if we had something called h of x that came from f of g of x? Can you look at this final answer and now go backwards to say what could have been, and there's more than one answer, but I'm just going to go with the easiest way to do this. What could have been the f and the g that would have made this the final answer? So again, remember that this means the g function goes inside the f function. So if I clearly see something that's inside of something else, I'm just going to go ahead and call that the g. And so where would I have to put this into to get this final answer? Well, wouldn't I just have to put it into something with a square root? And don't we normally plug that into the x? So now just make sure that makes sense. If f of x was this and g of x was this, and I tried to do the composition f of g, would I get what they have for the h of x? Yes. So pause if you want and try to do the next one, and then I'll show you the answer. Again, gonna be lazy, and just if I clearly see something inside, I'm gonna make that the g. And then what is happening to that is gonna be my f. Okay, I'm now gonna do the last two homework problems for you, because that's the easiest way to kind of show, because they're a little bit different. They're done with graphs and with points instead of equations like we've been doing. So here is an example of problem 22. So it's asking us for h plus k of -1. So remember when we were adding or subtracting or multiplying, we could just find the two things separately and then do what it says. So I'm going to find h of -1, which means I go to -1 on the x-axis, and then I find the h function, which is the blue function. So I need to go up. When x is -1, do you see that the y would be 2? So 2 is one of my answers. And now I'm going to do it again with k. So I'm going to go to -1 on the x and find the k. What do I get? -3. So +2 plus -3 gives me -1. Okay, we need to do the next part. All right, now it's k minus h of -2. So let's do the k first. At -2, the k is -3, and the h at -2 is 1. So I need to do -3 minus 1. And this is obviously easier with some paper in front of you, but I'm just trying to show you kind of how I'm doing this. So now k divided by h. Again, I'm going to find out what's happening at 3 for both functions and then divide. So when I plug in 3, +3 to k, I get -1. Do you see that? At 3 on the x, if I go to the k function, which is the red one, I get -1. If I go to 3 and find the blue function, it's right there, which means it is 0. So k over h is really this, 3 over 0. But remember, we never want the bottom to be 0 because it makes the function undefined. So if you end up thinking you have some kind of fraction with a 0 in the bottom, you erase that answer and click on undefined. All right, now we need to multiply. So we're going to go and find out what's happening at 2. At 2, the k function is -1 and the h function is +1. So if I multiply those together, I get -1. And now finally a composition. This is where it's a little trickier because I need to make sure I find out what is my answer when I plug in -3 to the h. I need to get that answer and plug that into the k. And by plugging in with a graph, I mean finding out what the value is at that point. So -3 is like my x. I need to find out what's going on with the h graph at -3. So at -3, the h function, the blue function, is 0, right? So now I need to plug that into the red one, which means go to 0 and see what's happening at the k graph, the red graph, -2. So the compositions are a little trickier because you need to do it in order from the right to the left. So here's another one. I'm going to see what's happening at 4 with the k function. And then whatever answer that is, I'm going to see what's happening there on the h function. So let's go to 4, see what's happening at the k. It's 0. So now I'm going to look at 0 and see what's happening with the blue function, and it's at 3. And then finally, this is just a different way to write the exact same thing. So I'm going to see what's happening at 0 for the k function, get an answer, and see what's happening there at the h. So 0, the k function is -2 at that point. So now I'm going to go to -2 and see where's my blue graph at 1. So I started at 0 and I found out that the k is -2 there. So then I went to -2 and found out that the blue graph was 1 at that point. So that's how you do it with the graph. It is a little tricky, so definitely try that a couple times if you need to. And then we're going to do the exact same type of thing once I get back in here with the last question. Okay, so here's 23. It's going to be the exact same type of idea that I was just doing. It's just instead of being able to look at a graph to find the points, they're just listed. But we still need to do it in order, meaning we first need to put the 0 inside the f. So remember what that means. That means 0 is the x value, and we're trying to find the y value that goes with it. So looking at my points they've given me for the f function, where is 0 for x? In that middle point, 0, 2, which means when x is 0, the y is 2. So my first answer is 2. When I plug 0 in for f, I get 2. So now I'm going to start all over again and look at the g points and see what's happening at 2, meaning when x is 2, what is happening? Interesting answer. Just a coincidence. Don't memorize that always happens because it does not. So I get 0. So just make sure you're thinking, this is my x. Let me put it in f and get the y. Then let me put that value into the g as the x and see what I get for the y for that one. Okay, that's about it for this one. If you need more help or have questions as you're doing the homework, do not hesitate to send the questions to me or just text me a screenshot of what you're working on. And if I'm available, I'll help you right then. If not, I'll send you some help when I'm able to. Good luck. Talk to you later.